Alright, so last time we talked about hyperbolas with the center at the origin, but the transverse axis was along the x-axis. Now we're going to have that transverse axis along the y-axis. Okay, so we'll have the equation. Notice now the y squared is first. The a squared still stays there at the bottom, at the beginning there, but the y squared is first. So y squared over a squared minus x squared over b squared equals 1. You still have that same relationship, b squared equals c squared minus a squared. Now what you have is you have your distance a up to a vertex. Come on, man, this thing's giving me trouble all day. Vertex a distance, and wrapping around your focus c distance, right? Oops, I didn't draw that very good, but vertex focus, and then your conjugate axis will be b distance away for your imaginary rectangle for your asymptotes. Oops, I didn't draw that through B. So your asymptotes equations will be y equals plus or minus. So you go up A over B. A over B x. Okay, a little better picture, explanation right there for those asymptotes. Okay, let's work some examples here. So we need this equal to 1, so the first thing I'm going to do is I'm going to divide everything by 9 here. So I have y squared over 1 minus x squared over 9 equals 1. So this is of the form y squared over a squared minus x squared over b squared equals 1. So I know this thing opens up down. Since a squared is 1, I know a is 1. Since b squared is 9, I know b is 3. So the second thing I'm going to do, here's number 1. Let me kind of get a picture of this thing. I know the center's at the origin, 0, 0. I'm going to go up A for my vertices because I know it opens up down. And then B is 3, 1, 2, 3. So that's the corner of my rectangles. I go up 1 over 3 from the center. I'm going to put a dot. I'm going to go down 1, left 3, and put a dot for my other corner. I'm going to go right 3, down 1 from a corner, and then up 1 over 3. There's the corners of my rectangle, so the asymptotes extend through the diagonals of that imaginary rectangle. So I can kind of see how wide it is approximately when I draw this thing. Now we don't know where the foci are, so we need to solve that. So number 3, we know b squared equals c squared minus a squared. So 3 squared equals c squared minus 1 squared. C equals plus minus root 10. So that's 1, 2, 3, and a little bit is about where that focus is. Down from the center, 1, 2, 3, and a little bit is where that other focus is. There's my focus, there's my vertex, there's my vertex. Right, so my vertex is 0, 1. My focus is at 0, root 10, and 0, negative root 10. Right? Again, it wraps around it. Let's get a point. This time will be off of the focus, so to the left and right of the foci. Now the foci is at root 10 and negative root 10, so what I'm going to do is I'm going to let y be plus or minus root 10 into my equation. So plus or minus root 10 squared, right, I'm using this equation right here, over 1 minus x squared over 9 equals 1. So I got 10 minus x squared over 9 equals 1. So I got x squared over 9 equals 9. So x squared equals 81. X equals plus or minus 9. So my points will be 9 plus or minus root 10, negative 9 plus or minus root 10. So clear out here at 9 root 10. So this is pretty wide. Anyways, I put those points on. Same thing here, put those points on. I got a little better picture here. let's see right here. Here's your 9 root 10, your 9 negative root 10, negative 9, and so on. And I already drew those asymptotes going through. So the asymptotes plus or minus a over bx. I'm going up a, 1, and I was going over b, which is 3, and I was putting a dot. All right, so plus or minus 1/3 x. So y equals 1/3 x is that asymptote. Y equals negative 1/3 x, which I didn't draw that very good. It's not supposed to touch there. Is that asymptote. All right, let's keep going here. Find an equation of a hyperbola that has one vertex at 0, 3, foci at 0, negative 4, and 0, 4. Let's get a picture of this thing. There's one vertex. There's one foci. We know it's going to wrap around the vertex. We know this opens up down. So we already know it's y squared over a squared minus x squared over b squared equals 1. Now the other focus is at 0, negative 4. And we know if one of the vertices is at 0, 3, then the other vertex is at 0, negative 3, right? That's just a guaranteed there, since the center's right there. At the origin, we know, here's our foci, the midpoint between them must be right in the center, right? 0, negative 4, 0, 4, midpoint be a 0, 0, okay? So we know y squared over a squared minus x squared over b squared equals 1. That much we know. And we also know our vertex, distance 3. We know our c here is 4. A is 3, c is 4, opens up, down. So I'm going to go b squared equals c squared minus a squared. B squared would be 4 squared minus 3 squared. So b squared equals 7. So b equals plus or minus excuse me, root 7 on that. And now we're going to go, okay, well, y squared over a squared, which is 3. So 3 squared, a squared, minus x squared over root 7 squared equals 1. So we got y squared over 9 minus x squared over 7 equals 1. There's our equation. Okay. Let's get our points. Points left and right of foci. Now the focus is at 0, 4, right? It's at 0, 4. So I'm going to let y be 4 so I can get this point out here. And then the other point out here. So y at 4, and I'm also going to let y be negative 4. So let's let y be plus or minus 4 here into our equation. So plus or minus 4 squared over 9 minus x squared over 7 equals 1. And that ends up being, let's see, x squared over 7 equals 7/9. X squared equals 49/9. X equals plus or minus 7/3. Okay, so we have 7/3 plus or minus 4. And then we have negative 7/3 plus or minus 4. So 2 1/3 and I'm up 4. 2 1/3 and I'm up 4. There's the point. 2 1/3 down 4. 2 1/3 down 4 right there. And then negative 2 1/3 up 4. There's that point. Negative 2 1/3 down 4. There's that point. So there's the points on our parabola. The only thing we're missing here, it's going through the vertex, is our asymptotes. So our asymptotes, we go up A, so up 3, and over B. Now B is root 7, right? So that's between 2 and 3. So about right here. So up A over B, put a point. Up A over B. Up A over B. Okay, so plus minus root 3 over 7x. I'm going to go down 3, right, root 7. I'm going to go down 3, left, root 7. I'm going to go up 3, left, root 7. There's my imaginary rectangle. The asymptotes go through the center and the diagonals of that rectangle. Okay, so again, the only thing I'm missing here is my diagonals, my asymptotes. Alright, so we've discussed this already. If our transverse axis is the x-axis, we've got our equations for our asymptotes. There's a little picture of that. If our transverse axis is along the y-axis, there's the equation for those asymptotes. Let's analyze this equation. We got y squared over 9 minus x squared equals 1. So it's in the form y squared over a squared minus x squared over b squared equals 1. So I know this thing opens up, down. The transverse axis is horizontal, in other words. I'm sorry, it's vertical. Vertical, in other words, it's either the y-axis or parallel to if the center's not in the middle. Now, a squared is 9, so a equals 3. B squared is 1. B equals 1. So let's do our b squared equals c squared minus a squared. So I got 1 squared equals c squared minus 3 squared. So c equals plus minus root 10 here. So our asymptotes would be y equals plus or minus up a over bx. Okay, so if I could draw this thing, center's in the middle. A distance is 3, there's a vertex. A distance is 3, there's a vertex. I know my B distance is just 1, so up 3 and over 1, right? Here's our B distance, which is 1. Here's our A distance. So here's the corners of my rectangle. I could kind of draw an imaginary rectangle here. So I know my asymptotes go through the diagonals as well as the center there. So y equals up 3 over 1x plus or minus on that. So plus minus 3x are my asymptotes. And of course I could draw the rest of that. C is root 10, so I have 0 comma root 10 and so on. Okay. And there's our focus, 0 root 10, 0 negative root 10, and so on. Now let's do this equation here. Notice it is not equal to 1, so the first thing I'm going to want to do here is I'm going to get this equal to 1, so I'm going to divide by 36 on both sides. Sorry about that, I thought I'd skipped one for a minute. So we got x squared over 9 minus y squared over 4 equals 1. Notice the x squared is first. So this is of the form x squared over a squared minus y squared over b squared equals 1. So this thing opens right and left, kind of like the ones we started with. Center's at the origin again. If a squared equals 9, I know a is 3. If b squared equals 4, I know b is 2. Okay, so now I'm going to say, well, that means b squared equals c squared minus a squared So 2 squared equals c squared minus 3 squared. So we got 4 plus 9, we got 13. C squared equals 13. C equals plus or minus root 13. Let's make a picture of this thing. Center's right here at the middle. A distance away is my vertex 3. This opens right and left. My focus is, so here's A distance away. My B is 2 for my rectangles. Asymptotes here, right? So we know our C is root 13. Well, that's between, what, 3 and 4? So there's a focus. C is root 13 distance away. So the focus is at root 13, comma 0. The other one's at negative root 13, comma 0. And this is kind of the shape of it here as it goes through the vertex. Okay. The asymptotes. I'm going to go up B. So up 2, up B, and I went over A, which is 3. Right, so my asymptotes, my oblique asymptotes or my slant asymptotes are plus or minus up B over A x. So in this case, up 2 is my B, and 3 is my A. So y equals, here's my y equals 2/3 x asymptote. Here's my y equals negative 2/3 x down to right 3 asymptote. Okay. There's a little better picture of that. Alright, so what if we don't have the center right in the middle? Well, if it opens right or left, x is still squared, but it's x minus h squared. We're moving to hk. And then if it opens up down, we got y minus k squared. So again, hk is now our center. Okay, so we just have either the transverse axis being horizontal or the transverse axis being vertical in the second scenario on the right there. So let's do some. Find equation for the hyperbola with a center. So here's our hk, negative 1, 2. Here's our hk, negative 1, 2. A focus, let me try and draw this first. Negative 1, 2. Okay, so we're like, alright, here's, oh, come on, for the love, don't be doing this to me. Okay, negative 1, 2, there's our center. One focus, negative 4, 2. One vertex, negative 3, 2. Gosh, what's wrong with this thing? So there's our vertex, there's our focus, there's our center. So I know it wraps around. I don't know how wide this is, but it's going to wrap around. So I'm like, hey, this is giving me the A distance. So my A distance from the center to the vertex, it looks like it's just 2 distance away. My C distance from the center to the focus, it looks like it's 3 away if I count it. So let me go to the other side of the center. Here's my center, and let me go 2 distance away. 1, 2. Here's the vertex. Let me go 3 away from the center for the other focus. And I kind of have so far what this is looking like, knowing that A is 2 and C is 3. So I'm now going to say, well, I know it's x squared over A squared, except I have hk. I have a different, it's not x minus 0 squared, it's x minus h squared because I've moved the center. So it's this equation that opens right or left. Okay? And then I say, well, the only problem is I don't have B. So let's find B. plus minus root 5 on that. So my asymptotes, in fact, let's do the asymptotes now. Now that I know b, so b is up 2 and a little bit. So 1, 2 and a little bit. It's up root 5, and it's over a, which is 2. Right? So y equals, we normally have plus or minus up b over ax, but in this case we have a different center hk, so it's y minus k plus or minus b over a x minus h. Okay, so we have y minus, remember our center, or hk, so it's y minus 2 equals plus or minus, I'm up b, I'm up root 5, and I'm over 3. I'm up root 5, and I'm over 2. My a is 2. X minus my h is negative 1. So x minus negative 1 is x plus 1. There's the equation for both of my asymptotes. There's the equation for both my, both my asymptotes. There's my other asymptote. Okay. Now the only other thing I'm missing here is I never wrote the equation for this. So let me go back to here. I now have a and b, and I have hk. So x, so it's step 5. X minus my h, negative 1, so x plus 1 over a squared, so 2 squared, minus y minus my k, which is 2, over my b squared, and my b is root 5, so root 5 squared is just 5. Alright, so there's our equation. X plus 1 quantity squared over 4 minus y minus 2 quantity squared over 5 equals 1. There's a little picture of that thing with our asymptotes and our focus, all those points. You may even want to use graph paper when you're doing this. Alright, let's analyze it when we've got it in this kind of crazy general form. I'm looking at this, I'm like, okay, I'm going to have to complete the square here. Notice my y is positive, so that I'm going to write that first, my 9y squared. The 9 is positive there. So it's going to be like y minus k squared over a squared. I'll leave a space, minus x squared plus 4x. I'm going to take this minus 68 to the other side. So I got negative 68 right here. Now I got to complete the square. So I'm going to go ahead, let me take a y out. Let me take a negative out. Equals negative 68 over there. And then I am going to complete the square. So let me take 6 divided by 2 and square it. That's the number I need. So 6 over 2, 3. 3 squared, 9. I'm going to add 9 to this side. Now, I really added 81, so I'm going to add 81 to the other side. Over here, negative 4 over 2 is negative 2. Negative 2 squared is 4, so I'm going to add 4 to this side. But in all reality, I subtracted 4 from that side, so I'm going to subtract 4 from the other side. Okay. So this ends up being, what is that, 9? So I've got 9, I got y plus 3, minus x minus 2, x minus 2. Remember, we want this thing equal to 1. So now I'm going to divide everything by 9. So I want that to be 1 right there. So I got y plus 3 squared over 1 minus x minus 2 squared over 9 equals 1. Okay, so what we have is, you know what, I'm going to have to erase this. I have room here, sorry. No, let me just put that up top now. was that? Y plus. Okay, we have that. So we know this thing is of the form y minus k squared over a squared minus x minus h squared over b squared equals 1. It opens up, down. You notice the y squares first, right? Opens up, down. So the center, hk, so x minus h, x minus 2, so here's my h, 2, and my k, y minus k, y plus 3. So that's y minus negative 3, so my k's got to be negative 3. So my center is 2, negative 3. That's my hk. Okay. And then I know my a squared is 1, a squared is 1, so a is 1, b squared is 9, so b is 3. So I'm going to go ahead and do, after I've completed the square and gotten the equation, step 2, I'm going to say b squared equals c squared minus a squared, so I can find my c. So I have 3 squared equals c squared minus 1 squared, so c equals plus minus root 10. So the center of this thing, 2, negative 3, right there. It opens up, down, so I'm going to go up 1, up a distance away, and down, oh come on man, I hate it when it does this. Up a distance away, down a distance away, 1. For my asymptotes, I'm right 3 for the, so this will be, so up 1 over 3 for the, and then 3, up 1, left 3, down 1, left 3, down 1, right 3. So here's the imaginary rectangle, which we're going to draw the asymptotes through that. Kind of tells how wide it is. So the asymptotes be y minus k equals plus or minus, this will be a over b, up a over b, x minus h. So y minus k, my k is negative 3, so y plus 3 equals plus or minus 1 over 3 x minus 2. There's the equation for both of my asymptotes. Both of my asymptotes there. Okay. Now the only other thing we didn't put on here is our foci. So the c is root 10 away, right? So that's like 3 point something. So 1, 2, 3 point something. There's one of our focus. It's like right here. So it's at an x value of 2, but then the focus is at negative 3 plus root 10. And then the other one from the center C is down 1, 2, 3 and a little bit. So it's about right here. So it's at an x value of 2, but it's negative 3 minus root 10. That's where the other focus is. All right, remember, it wraps around those foci. I got a little better picture of that thing right here. And there's our focus points on there. Okay. You notice the asymptotes, the equations for our asymptotes, both of them there. Okay. All right, let's finish this off. We've got an application. Suppose that two people standing 2 miles apart both see a flash of lightning after a period of time. So lightning, by the way, follows hyperbolas can analyze those or model those. Okay. So we got two people standing 2 miles apart. Let's see if I can draw this thing. Here's our center here. Okay, so two people, I've got them. I'm going to have them standing 2 miles apart. Now 1 mile is 50. Oh come on, 50 to 80 feet. Okay, so this would be. I'm going to call this person A. So they're at 5280. That's 1 mile from the center. The other person here, person B, is a mile away because they're a total of 2 miles apart from each other. Okay. So what we have is the two people are at my foci. Okay, they're at my foci of this hyperbola. If you can imagine this hyperbola, kind of modeling this here. And it says, after a period of time, person standing at point A hears a thunder. 1 second later, the person standing at point B hears a thunder. Okay, person B is due west, it's just straight west. Person at A. Lightning strike is due north of the person, so it's right here. It's that point XY. So I'm going to call this point P. Okay, and it's right above them. So person A hears the lightning strike. However far this distance is, we don't know. 1 second later, person B hears that lightning strike. Okay. Now, if you remember when we began this section, I said the difference between the distances, so the distance from point P to the person at B minus the distance from point P to the person at A is a fixed amount, it's 2A. That's the definition of a hyperbola. Well, the difference is, it was 1 second later. 1 second later, the person at B hears a thunder. 1 second later than the person at A. So their difference. Now, what you need to know is that sound travels 1,100 feet per second. So that's the difference. 1,100 feet is the difference between that because they hear it 2 seconds later. So that's going to give us, if I divide by 2, that's going to give us our A, 550 feet. Okay. Now we also know, number 2, there's 2 miles between them. Right? Remember, this is distance C, that's distance C. So 2, in other words, 2C is 2 miles between them. So 10,560, in other words, C must be 5280 feet. Right? So C is 5280 feet. So that kind of gets us going for the relationship B squared equals C squared minus A squared. So B squared would be 5280 squared minus A squared, which is 550 squared. So B squared ends up being 27,575,900. That's B squared. So we can start writing our equation. So I have x squared over a squared, that's 550 is squared, right? 550 squared, minus y squared over b is already squared, so 27,575, 900 equals 1. Okay? Now, what I want to know, where did the lightning strike occur? In other words, what's that distance, right? So I'm going to say, well, I know person A is at 5280 feet out. So that's my x. I'm going to let x be 5280 feet. And then I'm just going to solve for y because it's on that hyperbola. That'll tell me the height of where that lightning strike actually occurred. So I got 5280 squared over 550 squared minus y squared over 27,575, 900 equals 1. So let's see, I got that. So this will end up being y squared over 27,575, 900 equals 27,575, 900 over 302,500. So y squared equals, so I multiply both sides by 27,575, 900, and then divided by 302,500, and I get 251,381,9044. Square root both sides, and I get 50,138 feet. That's where the lightning strike occurred. 50,138 feet due north of that person standing at point A. Okay, here's a little better picture of that. Obviously, my drawings are not the greatest in the world. There's a little work for that. Thank you so much for listening.